All right, well, we'll go ahead and get started. So Andy and I are going to be presenting on updates for two different work streams, which are in the Cooling Environments Immersion group. So these two work streams are not really related, I think, in many ways. We're totally independent of one another, but we're sharing a time slot. And really, if we think about the intent behind them, me leading the Immersion-Requirements group, and Andy on the Total Cost of Ownership, or TCO group, at the foundation or heart of these groups is really the desire to enable immersion cooling by identifying best practices and also providing the community with tools to justify adopting and operating and using and committing to end-of-life maintenance for these new technologies. So we'll talk with you a little bit here today about some updates from each of our groups. Now, the first question really is, where are you on your immersion journey? And depending on where you are, and depending on when you stood up, when I was asking who you are, I think different types of resources, tools, and references are going to be more useful than others. So if you're on the scoping and business justification side, you might appreciate that you get efficiency gains and sustainability gains. You might appreciate that you get a lot of extra performance with improved thermal management that comes from immersion cooling. But you also then have to justify from a business case. So something like a TCO model comes really in handy at that stage, right? If you are looking to adopt, you have a lot of decisions about what type of immersion product you actually want to bring into your facility. If you're looking to adopt long-term, you have to think about managing the life cycle of those products. So having resources available is really, really critical to help facilitate that entire process, to answer questions like these. So what tools are there? How do I decide from all of these options? What types of codes and standards exist? What best practices should I implement? And these are common questions that we on the OCP Immersion Committee are trying to help to address for the community. The Immersion Requirements group is specifically focused in a particular space. The TCO group is in a particular space, Fluids and Requirements is, but all together we're trying to holistically prioritize what are the most urgent needs to actually provide feedback to the community. So Immersion Requirements itself, I see as almost the final mile of a lot of the immersion-related committees. We get a lot of questions by people that are interested in engaging more, but don't know which group makes the most sense for them to join. So really here, what you see is my relatively crude map of where Immersion Requirements sits. You have early pipeline groups, which help to identify key hurdles, identify key problems in the industry, key gaps. You have mid-pipeline groups like Fluids and Materials or Signal Integrity that are really focused on creating content, specific product guidance, looking at different methodology that can be applied to this technology. Immersion Requirements synthesizes a lot of this guidance together and turns it into something that's digestible for the community in terms of best fit for product features and specifications. So really this is written, or these documents are written by the community, for the community, and the intent, as I mentioned, is to help to enable immersion adoption, to influence codes and standards, to provide system requirements, and to align on all the different ways that we can assess products out in the wild, right? So it's complicated, and it's difficult sometimes to find universal guidance, as we mentioned in the other talk. So Immersion Requirements really is a way to establish ground rules, right? There are two different types of work that I want to feature that are ongoing in the group today. The first is something that I'm really excited about. It's that we're opening up the existing Immersion Requirements, which is in revision 2.1, back open into the community for feedback. Okay, so we are just about to start this, and what we want to do is to take the document where it is today and make it better. We recognize that this document is a living document. It should evolve with this technology, and it should evolve to help push the bounds of what immersion is capable of, to really help to set targets, limits, guidance, address challenges in this space that balance performance and safety and also provide a runway for innovation. We don't want to be overly prescriptive and stifle innovation. We don't want to be underly prescriptive and maybe open our users up to having a safety incident. Okay, so our focus is here. We have a lot of content to cover in a very short period of time, so I'm not going to go through all of these, but what I am going to say is if you are interested in providing feedback, please scan that QR code now. It will also be at the call to action slide. It leads to a poll. It just allows you to provide feedback on what is important to you, what is a priority to you, and we can incorporate that feedback into the prioritization of which sections of the requirements group or requirements document we're going to focus on next. All of this started because we recognize there is a gap in the industry, and what we want to do is to continue to push ourselves to make that document better over time. There are a lot of places we can do that, but we have limited amount of time and energy and people, so help us to make sure that we're focusing on the right things. The second piece of work that I want to highlight is something that is called FMEA, or Failure Mode and Effect Analysis. All right, this is a very, very important work stream within our group. The reason why it's so important is that the end goal is for us to use the insights and content that's generated as a result of this work in the community to actually advise industry standards and codes bodies. This is one of the biggest hurdles right now to bringing in an immersion system into your facility, is understanding how it actually impacts things like building codes, storage limits, PPE required, special clearances that you might have to get, region-dependent or global-dependent restrictions. So the FMEA work that's ongoing right now actually started as a result of a presentation that Peter Cooper and I gave last year about auto ignition. And it led to a conversation about how do we understand the relative risk of ignition in an immersion environment. In this group, what we want to do is we want to actually address what types of failure modes or scenarios are most important to consider, the ones that are most likely, that result in the most severe effect, the ones that may not have safeguards in place, to identify and prioritize and rank those things so that we can provide better guidance into standards industries for where the limits of performance or product features should be. So we actually are also using this as an opportunity to try out new tools. So we've used Miro as a really nice collaborative board to be able to have simultaneous collaborative virtual engagement across our community. I included in here a screen grab example of what our Miro board looks like with these little Post-it notes. So in yellow, it would be a specific failure scenario. In red, it's failure mode, so what fails to lead to that scenario occurring. And walking forward, what safeguards are in place, what kind of notes and comments are there. We actually have a Miro board that we've created. We identified these component categories, so broke down the entire immersion system into 7 categories. And what we did is we then translated that into an assessment of normal operation, abnormal operation, single fault operation, and worked our way through all of the proposed and foreseeable failure scenarios related to ignition. There are over 1,000 entries in our Miro board. And what we're doing now is we're digesting those 1,000 entries that are actually relatively well organized, and we're turning it into a structured ranking, so a proper FMEA. The output of this will be specific guidance that the OCP community can provide to IEC, specifically for 62368, to actually have a new entry into that existing standard that's relevant for immersion cooling. The reason why this is important is because whenever you are a facility owner-operator, you're looking to adopt immersion cooling, you may have to talk to an authority having jurisdiction, some building code expert, some standards expert. Having something documented and formalized, well thought out, articulated, and quantified is a really nice thing to have, right? You don't want to have to do this negotiation or conversation every single time you want to deploy. So the output of this is going to be exactly that. It's going to be quantified, assessed. These 1,000 entries have been actually collected from across the OCP community, and we'll continue to engage with those other groups as well. So if you want to get involved in requirements, whether it's providing feedback on the next version of the requirements document, or if it's going to be looking at our FMEA once we get to the next phase and we open it up for community feedback, go ahead and scan that top QR code. If you haven't scanned the bottom QR code, that's the one that actually will link you to that live poll to provide me feedback directly. So I hope you all participate. If you see opportunities for us to continue growing, please reach out to me as well.
Okay, thank you, Amy. That was fantastic. So I'm Andy Young. I'm the CTO of Asperitas. I'm here to talk today about the total cost of ownership modeling work that we've been doing in the Immersion group. This is actually led by two of my colleagues who can't be here today, Eddie of Intel and Alison with Midas. They both can't travel due to work restrictions, and so I'm representing them. The reason I'm stepping up is that I've been picking up the torch that Rolf was carrying with the main modeling contributions from Asperitas that we've now been driving to completion of version 1.0 for the TCO model. So the TCO model of revision 1.0 is now in beta testing phase, and it's active in its development, and it's quite comprehensive in its scope. It goes across the entire ecosystem from silicon through to airside heat rejection or heat recovery and reuse, and has a lot of different inputs, and I'll show you some examples of those. And the outputs from the model really are designed to enable you to make good decisions and to compare different scenarios for different types of data center operations and cooling infrastructure options, from the tank or rack through to heat rejection. The model itself has a core engine. It sounds really good, doesn't it? But it's just an Excel spreadsheet. But within that, there's a lot of calculations that are done which are not, well, everything's available for you to take a look at, but you don't need to get into the details. You can work at 3 different levels of information input, which I'll show you today. So we structured the model into high, medium, and low level detail, where low is the most granular. We've used colors. If you enjoy colors, you'll see a lot of that today for different categories of equipment, and also 3 personas to help you see how the data is put in and the value comes out of the model according to IT and facility operations and financial, of course. We tried to reference what are in some ways standard KPIs, so PUE, water use, energy reuse. Those 3 are principally positioned in the feedback, but of course there's a lot of KPIs in financial terms which are shown as well. So let me show you a little bit. Well, here's a cartoon of the basic workflow through the model. So a user would use a front page to put in some key inputs, which is really setting the constraints of the model, typically done by the power availability at the utility scale. You can constrain it as well in other ways, so you can pin a value for the workload or the level 3 IT load, i.e. the rack PDU outlets. So you have the option to pin the model, constrain it in terms of power. You can cross-couple the models for different scenarios, so you have, as we like to call, an apples for apples comparison. And you'll see an apple on the next screen. If the first person to see that could shout out, I'll give them a cheer. So it's quite small, though, so those at the front have got an advantage. I'm looking at you, Eddie. So you can put in your inputs according to those personas. You can work at 3 different levels. Each level has got an increasing number of data entered, and the outputs are also categorized in these 3 different levels. So here's the model. You can see the colors. Anybody see the apple? Okay, you're the guy. And you can see we have 2 scenarios. You can call this perhaps it's sort of air cooling versus a typical immersion cooling example, but it doesn't have to be that. It can be different financial scenarios. And so in this case, we have a 10 megawatt data center. We have full utilization of that, of the capacity. And you enter in data for the cost of managed resources, such as electrical power or water, and the cost of infrastructure, such as the core and shell. You go into further details of input, as you can see on the top right, and there's links to different levels of data entry on the top bar. And also data outlet, or outputs, you can see go to more and more granular levels. On the top line, you can see the utility power constraint, which is free across the model because we are constraining the critical load in each of the scenarios, and you get basic high-level information on the financial outputs. The model also uses a library of equipment. Those colorful bars at the bottom right is where you can access and enter and modify the power, the cooling, and data infrastructure according to the equipment that you would use and the suppliers that you work with. So you can expand the model to introduce more equipment and therefore broaden your comparisons between different scenarios. There is an engine, as I said, inside it, and that's within the Excel spreadsheet. There is maths, but it's basic, and you get a level of detail that shows you where the energy flows through the data center in the form of a Sankey diagram. So we tried to be as open as we can. This is OCP after all, and transparent. So there's no macros as such at this point in time, so it's quite easy to read through. And there's a document, a technical document, and user document that helps you to navigate it. So if you enjoy TCO, come and join in. We are looking for beta testers. We have some, we need more. The user interface is updated, and we're really looking forward to hearing what you think about it. The calls are available on the 2nd and 4th Wednesdays of every month, and you can join. It's really easy using the QR code. And in particular, we're looking for testers, but also equipment providers to ensure that our library of equipment is comprehensive and accurate. So thanks a lot for your attention. I'm really happy to have this time with you today, and I'll hand this, well, I'll put it in between me and Amy so we can take your questions should we have time. Thank you.
Okay, yeah, go loud.
Yeah, so the question is, how do we navigate the information which may be proprietary in a model which is in an open platform? Yeah, so I think it's a great question. I mean, a lot of companies are not necessarily going to want to share information on the cost price of or the sale price of their equipment. The way that we handle that is that we can enter data for specific equipment. So a particular kilowatt rated chiller might have a certain dollar value, but if you want to obscure that in some way, you can express the cost price in proportional terms. So, you know, it's just a per kilowatt, this is how many dollars you're going to have to spend to procure the equipment. So we're giving options for information entry that can be either fixed, specific, or proportional, and that goes across cost and also floor area usage, water usage, energy usage, and so on. So we need that information to perform the analysis, but that's the one way that we can allow people to be slightly obscure about the specifics of the equipment. Thank you, Keith.
On that total cost of ownership, yeah, Andy, the problem is the how do I phrase this? Yeah, it's been a long day. So it's for comparing immersion against air cooling, for example, the total cost of ownership. If you were doing that, it's about the sustainability issue as well. It's the cost to the planet, you know, that we're always trying to. And one of the arguments I make is that you have reduced plant, you know, and I don't know whether that's something you can take into consideration. It's very subjective perhaps, but it's something that could help with the argument here, yeah, particularly for the use of water perhaps, or the fact that we don't, the elevated temperatures. So I don't know whether that's something you've considered or the group has considered in the TCO. I mean, cost is financial cost, isn't it? But there's an environmental cost.
Yeah, absolutely, John. So on the key performance indicators, you'll see some of those are financial. But of course, we also reference the energy usage, which impacts on OPEX, so that's tied into the financial expression. But also we use the water use efficiency, the water use effectiveness, sorry, and the energy reuse effectiveness. So we are, where they exist, referencing those KPIs that have a environmental impact. I'm sure there's some ways in which we can say that this data center uses this slice of the environment, so some better ways that we could capture that visually. But we're really looking for those standards to exist, and where they do, we will reference them. Okay, thank you, John.